Okay, let's do 12. What's 12 say? All right, so we have a little u sub here. Using the u substitution, u equals root x. Okay, so that integral is equal to which of the following? We just did one, I think, on number 10 that's very similar. So let's get this written down. So we got the definite integral from 1 to 4 of e root x over root x dx. Okay. Now, if you'll notice, it says is equal to which of the following. So it doesn't want you to actually evaluate all of this. So let's come over here to the board and look at it for a minute. Now, I think the selection of u equals root x is pretty obvious here. That's, of course, x to the 1/2. Just looking at these inside functions, that'll be the way to go. Du will be 1/2 times x to the negative 1/2, or if you prefer, 1 over 2 root x. All right. So let's go ahead and change those to u's in here. So 1 to 4, we're going to have to change the limits also. E to the u, and we have, if you look here and here, we have the root x on the bottom. I didn't, I neglected to put dx there. We have root x on the bottom. We have our dx. We just need a 2 here. Okay, if we put a 2 here, what you can do, it's like multiplying everything by 1/2. Okay, which means you're going to need a 2 to compensate on the outside. Basically, 2 on top, 2 on bottom. You can even think of it this way if you want to. I put a 2 down there, so let me put a 2 there, and I can move that 2 out here. But you got to have that 2, or else you can't get your du. All right? So it becomes e raised to the u du. Now also, don't forget the limits. These are x limits still, not u limits. So I take this x value 1, I'm plugging in here u equals the square root of 1, which is 1 still, and u equals the square root of 4, which is 2. That's probably sufficient. Let's look. All right, so it appears to be C for that one. Okay, let you look at it on this, see if you agree with C here. Indeed it is. All right, so we're satisfied there. 13. A little too far there. There it goes. That's 14. 13. All right, another little piecewise here. If f is defined by that piecewise function, for what's the value of the interval? Okay, so we just have to do it in 2 pieces. All right, so let's write it down here. F of x is 2 x minus 1. Okay. So 1 to 5 of f of x dx. Again, it sure does help to know these graphs. It really helps to know these graphs. So let's look, see if we can come up with something here. All right, we want to go from 1 to 5. So I'm going to graph it just to try to enhance my understanding here. All right, so from 1 to 5 is where we're interested. And according to this, f of x is just the constant function 2 until you get to 3. All right, so just this straight horizontal line. All lines are straight. There's a horizontal line until you get to 3 right here. Okay, so this is my function. I want to know, and really this won't matter what's to the left of 1, but this little rectangle is the first part of it, and that's a pretty easy, just a geometry problem to find the area of that. And then we have x minus 1 on the back side of 3. Okay, so we can just do a little function here. So we know if we plug 2 into x minus 1, you get 1. That's where it starts. Starts right there at 1. If you plug 4 in there, 4 minus 1 I'm sorry, I don't know what I just said. I plugged 3 in the one. 3 minus 1 is 2, so we start here. So scratch that last 5 seconds there. I plug 4 in there, I get 3. It goes there. If I plug 5 in there, 4 is kind of in the middle. If I plug 5 into that, I get 4. So up here at 4. Okay. So I need to know the area of that trapezoid also. And that's kind of a tiny diagram, but it's just me drawing it out. Now you could just geometrically find that, or you could apply the integral, wherever you want. We'll just do the integral since it's calculus. Maybe we'll do it both ways. So from 1 to 3, we're working on 2. So apply the antiderivative. That's going to be 2x evaluated at 3 and 1. Okay, if I plug a 3 in there, it's going to end up being 6 minus 2. So I just plugged a 3 in there and a 1 in there. So the area of this is 4. That's 4, which again, it's a 2 by 2 square. So that's pretty obviously 4. The other one is going to run from 3 to 5. And it doesn't matter, by the way, that the underline is here in this problem. Doesn't matter where they come together there anyway. So we're doing it for x minus 1 dx. Okay, so if you do your antiderivative, that's x squared over 2 minus x, which kind of looks like a trapezoid formula if you pay attention to it there. 1/2. Anyway, we won't go there. But you're doing it from 5 to 3. Okay, so plug 5 in there first. You get 25 over 2 minus 5. Okay, and then we're going to subtract 3 in there, which is going to be 9 over 2 minus 3. All right, so all that will calculate the area of this little trapezoid. All right. So if we take the parentheses off, that'll turn into a plus here. So let's just work this out. It's going to be 10 over 2 and 6 over 2. We're just going to add them up. So it's 25 minus 10 is 15. 15 plus 15 minus 9 is 6. 6 plus 6 is 12. Divided by 2 is 6. Trying to get ahead of myself here. So the area of this is 6, which makes that entire area 10. So let's go look back and make sure that that's what it wanted. Yeah, it wants to know the area from 1 to 5. So I don't know that I did that the easiest way, but some decent exploration for that problem. And I will see how long this is going to take. We'll just go ahead and stop it right here.